right, let's wait for that to pop up. And let's minimize this. All right, let's get going. All right, so let's see. We are let's recap where we've been and where we're going. Let's see. For the first week, we installed a database, right? The MySQL relational database, and setting up kind of like the environment that we were going to be using for the remainder of the semester. Then the second week, we focused on how to design the database, right? Using UML class diagrams that we represented the structure of the data that we were going to be working with boxes and lines and whatnot. Then last week, we focused on creating the database, right? Once we've designed it, we know what the structure of the data is, right? We took that, we saw, well, how do we actually implement it using a relational database? And then we spent a week about working and using the create table command from SQL to create these tables, the fields, the foreign keys, the primary keys, right? That would then be able to represent the database that we designed the previous week. Okay, so this time around, this week, we're going to assume that we have the database, it's been implemented. We have the tables already in place, and what we're going to do is that we're going to give you the database. We're going to give it to you, and we're going to populate it. Add some records in these tables, and then we're going to ask you to retrieve data, to query the data, right? So presumably somebody has already stored information in the database that you've created, and now we want to retrieve it, right? Presumably they might have hundreds, thousands, millions of records, right? We want to be able to see how is it that we retrieve it. We spent some time at the end of last week talking about relational algebra as being the foundation of the theoretical foundation on how folks were thinking of how is it that we were going to eventually interact with these databases. And so we're going to spend some time with SQL and see, well, SQL is one implementation of those ideas that came up with in the 70s of this relational algebra. So SQL implements a lot of the same features using a language that is kind of pseudo English like, right? Trying to make it so that it's simple enough so that non-programmers, folks that don't understand programming might still find it useful, right, and easy to get into, right? It lowers the bar of entry for folks that might not be as technical, and that they might still create some interesting queries and retrieve data that has been stored. Okay, so that's the plan for this week. We're going to be spending time on retrieving data. We're going to give you a database, right, which is basically the database that we've been working on for the last month or so. Right, that's the database, and then we have populated for you, and we're going to use it to practice how to retrieve data. Right, so that's the plan for this week. Okay. Also, there's an assignment due tonight, right, which is the creating the database assignment. That's due tonight. There's going to be a quiz later this week, right? That's Q2, which is on Friday. So that quiz is like the name suggests, is all about creating the database, right? So what the same things you've been practicing in your assignment, where you create tables and create foreign keys and primary keys, all that is going to be. We're going to ask you all about that in the upcoming quiz on Friday. Okay, so that's the plan for this week. Does anybody have a question? Does this make sense?
Yeah, will the quizzes continue to be multiple choice?
Yes, all the quizzes are going to be multiple choice, fill in the blanks, and they're also going to be random. I'm trying to introduce some randomness into the quizzes so that ideally not everybody gets exactly the same quiz. They're the same types of questions, but not everybody gets exactly the same, not in the same order, or the things are randomized. But yes, everything is multiple choice and fill in the blanks.
Cool.
And all the quizzes are going to be asynchronous, right? So they'll be made available the date that is made available, say this coming Friday, from midnight of the previous night, all the way through the midnight of that day, and then again for another day, the following day, again from midnight to midnight. So in total, you'll have 48 hours to complete. Most of them are going to be about 30 minutes, 45 minutes, and most of them are just going to have 5 to 10 questions. Okay.
Thank you.
All right, excellent. So let's get started with the assignment for this week. So we're going to be using the same exact database that we have been playing around for the semester. We've added just a couple more things: the follow table and an enumerated data type over here down below. But other than that, it's the same database that we have been playing around for for the last 3 to 4 weeks. Okay, so first we're going to learn how to import a database, right? So in I think it was the first assignment, we asked you to export a database, yes? And I believe that database only had one table. I think it was like the users table or something like that. Here we're going to practice on importing a whole database that has multiple tables, and those tables have been populated with data. And so we'll learn how to do that. We are assuming throughout the assignments that you are working with a database with a schema called db_design. And so all these instructions are making a couple of assumptions. And if you don't stick to some of these assumptions, please try to stick to them. Otherwise, the instructions don't work, right? And then we need to help folks try to fix things that are not quite working. So first we're going to import this database. It's going to blow away. If you already have a db_design, it's going to blow it away, and it's going to replace it with what we have here. Okay, and which is fine, right? We're going to be adding data as we go, and so always to give you a starting point to where we can make all these questions based on some of these assumptions. But it's basically the same database that you've been working for the last couple of weeks, but now it has data inside, right? So that you can query it. All right, so to get started, you're going to download the database, right? There's a link. You click on that. It's going to download it into, if you click on download here, click on download, and there it is. So notice that I had already downloaded earlier, right? And I had already unzipped it. So there it is. So before I had done this in the previous section. And so if you look in there, right, it has several SQL files in there, each one for a different table. So for instance, if you open up the users, right, you can open it up using SQL. You'll see that it's just a table. It's just it's just a SQL file that drops a users table just in case it's already in there. So it'll destroy your users table if you already have it, and then recreate it from scratch, right? And then it'll insert data in there. It'll insert Alice. It'll insert Bob Hope, Tim Dodd, Elon Musk, and Charlie Brown, and Daniel Craig. Right, so I'll insert those users into the users table. Okay. And so let's do that. Let's close this. So let's do it. Let's I'm here, and so to import it, you follow the instructions that are listed in the assignments. So basically, you say first you need a connection to get into the connection. And then go into server data import. So you go to server data import, the import from disk, and then you say import from dump project directory. And then you can navigate to the directory that we created. I think it's in downloads. It's this one right here, right? We say open. And from down below, you can say start import. So this is going to destroy anything you had before. And it's this one right here. You can say refresh, and there it is. Okay, you should double click it so that it becomes the default database, right? I don't know, do I have that in the instructions? No, it's like blah, 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 blah. Let's start blah, 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 blah. Okay, so I'm gonna put here, close case. Yeah, so double click the db_design schema on the left-hand side to make it the default schema. Okay. All right, excellent. So once we have that, you can start taking a look at what's in here. Right. So if you open it up, you see all the tables in there. You can just press here this button here, and then it'll retrieve the data in those tables. So there we go. We have a couple of users. So Alice, Bob, Tim, Elon, Charlie, and Daniel. We have a couple blogs. So these blogs, right? These are the names of the blogs. So Everyday Astronaut, SpaceX, Tesla, Tesla Daily, and Hyperchange. And notice that they have a foreign key over here of the user who owns these blogs, right? So for instance, Everyday Astronaut is owned by user number 3. User number 3 is Tim Dodd, right? And SpaceX and Tesla are owned by user number 4, which happens to be Elon, right? And then blog number 6, which is Tesla Daily and Hyperchange, are owned by user number 6, which is Daniel Craig. Okay, so I guess Charlie Brown doesn't own anything, Alice doesn't own anything, Bob doesn't own anything, I guess, right? Then if you look at posts, right, you'll notice that posts have foreign keys to the blogs, right? So these are posts all on blog number 2. So blog number 2 is this one, right? The Everyday Astronaut. So it looks like Tim Dodd, right, has been posting several things there in the Everyday Astronaut, okay, and so on and so forth. So you can take a look at all this data, right? You can look at ratings, for instance, is one that has some of the more records, and this says that there keeps track of likes and scores, right? Saying that so and so user. So-and-so user number 3 liked post number 1, right? And user number 4 didn't like post number 2. Okay. All right. Excellent. Let's see. Chat. Are foreign keys always place at the very end of the table automatically? No, really. When you create it, right, the create statement puts it wherever you want. Right, so if you take a look at the blogs, the way we send to SQL editor, the create, it's basically when you declared it, the order in which you put these in the original create statement, that's the order in which they're going to be displayed. Okay, by default, right? If you just say star, right, then they are displayed in the order in which they were declared, right? But you can change the order by specifying exactly which fields you want using a projection, right? And you can list the fields in the order that you want for the select statement. Okay. All right, sure. All right, so we're gonna be playing around with all this data. All right, excellent. So what else? Let's see what it's asking us to do. All right, so first of all, let's take a look at just plain old retrieving all the records, right? So that's easy. We're going to use the select statement, and this is what we're going to be playing around with the whole week, right? Basically the select statement. select statement, like it suggests, right? It allows you to retrieve data from an existing database, a whole bunch of records and tables. All right, so what we're going to do here is that we're gonna open up a SQL window here, maybe query 11 there over here, right? And we're going to start copying and pasting some of the queries that we're going to give you as demo, right? To guide you on what we're doing, and then we're going to ask you to do it on your own, right? So, for instance, we're going to ask you to copy this, right, onto the a SQL screen here, right, and then execute it. So we're going to execute it, and that's going to return all the users, for instance. Yes. Now this knows that the query is being done against the default database or schema, which is this one. Notice that it's bold, right, because we double clicked it, so it's default. Otherwise, this would not work, right? So yeah, so once we've done that, we ask you to now you try it, right? It says, now you try it in the same SQL screen, a couple of lines below, write SQL code that will return all the records from the blocks table. So we're going to ask you to do something like this, right? A couple lines below, right? Write out a comment. Notice that this is a comment here with the dash dash. It's a comment. You need a space right after the double dashes. Otherwise, it doesn't understand it as a comment. So this is select all blogs. So you are going to write something like select star from blogs. Right, you're going to write that and you're going to run it. And there they are, all the blogs. Okay, well, you're going to do that. We're going to ask you to please, at the end of every query, you put the semicolon like that. We're also going to please ask you to add an extra line here, a new line between the last query and the beginning of the next query. And we're going to please require you to please provide a very short little blurb sentence that describes the query. Okay? Right? It's a good practice, right, to always provide comments that describe your query. So, but you're going to have to do that your own, right? So I'm not going to give you that. Now you're going to save that. You're going to save that into an SQL file with the name querying relational databases.sql. You're going to save that. Okay, and that's the file you're going to submit, right? So the file is going to contain some queries that we're giving you and some queries that you are writing on your own, right? So it's going to be what we give you, what you write. What we give you, what you write, right? So it's going to have all the queries all the way through, and the TAs are going to grab your file and they're going to execute it against the database, the same database that you have, right? And hopefully, right, it comes out to be what is expected. Okay. All right. Excellent. That makes sense. All right. All right, so the next one, right, select the blog. So we're going to retrieve now. Here we retrieved all the records, right? Here we're going to retrieve a single record, right? A single record by its primary key. So presumably we know here we're going to retrieve a particular blog if we know that ID is 2. And you can check to see if that blog actually exists. Yes, number 2, there it is, right? So it's safe for us to copy this. Oops. Copy this, right? Paste it here, and then run this select. We run it, and there it is. It retrieved that blog with that ID number 2. Perfect. Excellent. Now we ask you to do the same thing. Retrieve a record from the post whose ID is equal to 3. You can check to see if there is indeed a post table whose ID is equal to 3. Really? We don't have it? I must have removed it. Okay, then I'm going to change it to 1. Sorry about that. Number 1. I must have inadvertently removed it. All right, so you're going to return the post record, right, from the post that is equal to 1. Okay, which is this one right here. All right, so you do that. Okay, so then we're going to retrieve a record using a criteria, right, like a predicate, right? So that's a criteria or maybe or predicate. Maybe it's a better description by predicate. So here, for instance, we're going to return a user whose username is Elon Musk, right? So let's do that. So let's go here, and let's always make sure to save. Right? We're going to paste that. I'm going to run that, and there it is. We got Elon, right? And there they are is record number 4. Okay, and then we ask you to do the same thing, right? Write your query that retrieves a record from the blogs table whose name is SpaceX, right? So you can do that. You can take a look at blogs, and SpaceX is number 3. So you're going to retrieve, right, the from the blog, right, the blog whose name is SpaceX. So you can use this as an example, right? This might be saying something, select star from blogs where name is equal to SpaceX, right? So for that, you do that on your own, okay? Then we're going to ask you to join 2 tables, meaning there's going to be some data that lives in one table and some data that lives in another table, right? So for instance, right, these the users contain some information about users. Blogs contain information about blogs, but they are joined, right? See, they're related. So the blogs and the users are related somehow, and the posts and the blogs are related to each other as well using this foreign key. So we're going to ask you, for instance, to retrieve all the blogs and their users, right? Who owns whatever blog, right? And print out the name of the user and the name of the blog. So to do that, we're going to have to retrieve some data from the users table and some data from the blogs table, right? We need to join them. And so to do that, right, we're going to use the following query. So let's go here and print that out. That's a little bit too small, too big. So I want the name of the user and the name of the blog. And the user's name I'm going to grab from the users, and the blogs I'm going to grab from the blogs. And I'm going to join them because I know that the blogs has a foreign key that refers to the primary key of the users, right? So I can run this. And there they are, right? So we see that Everyday Astronaut has a blog called Everyday Astronaut, and Elon has 2 blogs, one on SpaceX and one on Tesla. And we have Dan has 2 blogs, one on Tesla Daily and the other one on Hyperchange. Okay. Now for you, I'm going to ask you to join 2 tables as well. Write a SQL statement, right, that will retrieve all the blog names and the posts in the related records in the post table. So basically join these 2 tables, the blog and the post. Notice that the blog has each post has a reference to the blog it belongs to. So you're going to join these 2, right? And you're going to retrieve the name of the blog and the post, this post over here. Okay. Let's see, question on the chat. Does join create a new table? No. So all this is retrieving, right? So when you join, right? Basically you come back with a result set, right? Looks like a table, actually, right? It looks like a table, right? Just like these, right? These are actual tables. These are just this data, right? In the table users. Right, and this is data in the blogs table, but this is data that we have retrieved from one table in the other, and it generates something that looks like a table, right? It has rows, it has columns, and you can actually treat it as if it were a table, even though this is not a table, right? It's just data that we're spitting out that we have retrieved from different tables, and this is a result set, okay? And so we'll see an example of that in a minute. Can you only join tables that are connected by foreign key? No, you can. So foreign keys is just an additional safeguard, right? When we know that one field is going to have values that are referencing values in another table, right? We could have just said, users has an ID. And blogs has a user, and we know that the values here match the values here, right, in the user. And we could have just said that, right, without foreign key, without primary key, and all these queries would still work, right? All these queries would still work, right? The reason we go beyond and just make fields equal to each other and whatnot but we go a little further and say, oh, wait a minute, but you're a primary key and you're a foreign key, right? We went further and said, well, not only do you have a unique value here, and not only are these values, I'm going to make sure that the values that I put here are from values that are from here, right? We went a little further and said, well, these are primary keys and these are foreign keys that reference this primary keys. The reason we did that is that we want the database to enforce certain constraints, right? We want the database to go further and say, enforce referential integrity, okay? And what that means is that because I have here, here I have two records, right? These two records that are referencing user number 6 over here, right? The database is not going to let me remove this record, right? Because it says, wait a minute, you have other records that are referencing you. And if I let you remove it, you're going to leave these guys hanging there, right? That are not going to be referencing anything, okay? That's why we went ahead and made these two fields point to each other. And we said, this is a referential, this is a foreign key that references the primary key over there. We could have just not done that, right? And this would still work, but it would have not enforced the referential integrity. It would have let us remove this parent record without caring what happened to these children records, right? So foreign key, primary key adds that level of checking, of enforcing certain rules. That's a great question. Can you again? In the SQL command, what does blogs word after join refers to? In the SQL command, what does blogs? Where are you here? Here, you mean? Is this what you mean over here? Yes. Yeah, so what this is saying is that I'm going to join these two tables, right? Meaning I'm going to grab some columns from the users table. I'm going to grab some columns from the blogs table, right? What this does, it creates a like a cross product, right? It creates all the possibilities between these two tables, right? But as we saw earlier, as we saw in the previous lecture, right? We talked about join being a combination of two things, right? Of first, creating the product of all the combinations of all the records between users and all the records in blogs, and that creates a huge set of combinations, right? But not all combinations make sense, right? And so we want to filter and say, well, we don't want all of them, right? Because there's going to be a whole bunch of blogs that are related to a whole bunch of users that they're not their owners, right? Why would I want that? I only want the subset. So there's the second part of the join, right? I only want the subset where there is a foreign key, primary key relationship between the two, right? So filter out all the ones that don't match with one another. I don't want those. I don't want to keep the ones that have this predicate be true, right? So this basically says these are the two tables that I'm going to bring together, right? And the way you would implement this, underneath, behind the scenes, the way you would implement this is that you're going to have an outer loop that's going to loop through the records in the users table, and for each record, I'm going to loop an inner loop. I'm going to iterate over the blogs table, right? And then I'm going to look at this one, and this one, and then for each one of those combinations, I'm going to compute whether this is true or not, right? So it says, here's users, here's the blog. Basically, I'm saying, is this blog belong to that user? No. Okay, I'm going to go to the next one. Does this blog belong to users? No. Go to the next one. Does this belong to this user? Yes. Ooh, I want that one. Okay, and I'm going to keep going. Does this one belong to? No. Yes. Yes. No. No. Yes. 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 Once I've gone through, I will put all the ones that match in the result set, right? In this result grid. Once I went through all my blogs, I'm going to start all over. I'm going to advance my user, and I'm going to go again all the blogs, right? And see the ones that match, and I'm going to add it to my result set. Okay. Once I'm done, I'm going to go again, next user, right? And I go again. So notice that I am considering all possible combinations. So one user, all the blogs. Next user, all the blogs. Next user, all the blogs. Next user, all the blogs. basically I'm going through all the possible combinations. Yes? And for every single combination, I am filtering out the ones that don't matter to me, right? Only the ones that match, and this is true, right? Where they are related to one another. But what this says is that I am actually considering all possibilities. That's where the cross product comes in, right? That I'm looking at all the cross product, and then I'm only filtering the ones that I want to keep. Make sense? All right, so let's move on. Right. So yeah. So this syntax, right? This syntax of joining is also referred to as the natural join or the inner join, and is the most common type of join that we're going to be using throughout the semester, right? And you'll see this quite a bit whenever you see SQL code. Now there's a syntax that is a little bit easier to read, which is referred to as the implicit join, right? So this syntax over here is going to be equivalent to this over here. Okay, the next example is going to be an equivalent query that is a little bit easier to read, I think, right? And it's called the implicit join. So basically, this query is identical functionally is identical to the one before. Let's copy this, right? And I'm going to copy it down below here. So basically notice that I even gave it the same name. See that? The same comment. So select the users and their blog names. See that? Because these two queries do the same thing, right? So let's run the first one. Let's run the first one. And let's run that. And there we have, right? We have the user and the blog name. User, blog name, blah, 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 blah. Now, if I run the second one, it's going to generate exactly the same results. See that? User, blog name, user, blog name, user, blog name. Okay. But notice that this might be a little bit easier to read. This says that I want the username and the blog name, right, from these two tables, right? Again, this is going to generate what? Generates the cross product. But where, right? I only want the records where the following is true, where the user ID is equal to the blog user, right? So basically, I'm filtering all the records that are coming through that are considering all the possibilities, right? I'm only going to keep these records that meet this criteria or this predicate. Okay, I think this syntax might be a little bit easier to read, and you'll see in actual implementation in industry, some folks will prefer this syntax, or some folks will prefer this syntax. Okay, this is referred to as the explicit joins, and whereas this is sometimes referred to as the implicit join, right? That makes sense? So anyway, so we ask you to do that, and then we ask you to write an implicit join for the query that you wrote before, right? So here you had created a join between the blog and the posts, right? So we're asking you here to rewrite it, write an implicit join that retrieves all the blog names and relates to, okay, add a comment. So basically, it's the same query as before, but writing it using an implicit join. Okay. Okay. Remember, all these you need to add your own comment, right? Maybe just a little line, a little blurb explaining what you're doing, and then save the file. Okay. All right. All right. So let's So here's a query that uses the joins, and before we had a query in the where clause that that was just filtering with a non-key field, right? You're just checking to see retrieve all the users where the username was Elon Musk. Well, you can combine the two. You can combine in the where clause. You can combine predicates that are used to join tables with predicates that are just filtering on a particular field, right? That is equal to something, right? So in this case, it's doing what? It's selecting the usernames and their blog names for a particular username, right? Whereas here, it was retrieving it for all users, right? Here, I'm filtering the original query from above, but I only want the ones from Elon. Okay, so if I copy that, bring it over, right? In the previous query, it was retrieving to me, it was retrieving all blogs, right? And their users, right? Right. But if I now add at the end, if I add to the previous one, right? If I add that I only want the ones whose username is Elon, and I rerun this, okay, notice that I only get the blogs and the username for that specific username. See that? Right. So this is just illustrating that you can combine, using Boolean operators like and or, right, to combine and create more sophisticated queries. Okay. All right. Let's go a little further. Let's now take a, up to this point, we've been joining these two tables, right? Just the username and the blogs. Let's make it a little more interesting. Let's join now 3 tables. There it is. See that? We're going to join user with blog with post, right? Because remember, all these 3 tables are related to one another, right? The posts point to the blogs right here. See that? Whereas the blogs point to the users right here, right? And then the users don't point to anybody, right? So there's a one-to-many between user to blog, and there's a one-to-many between one blog has many posts. Yes? Okay, let's see in the chat. What if you wanted and Elon Musk or, yeah, exactly. You would put it in parentheses. Perfect. That's what you would, yeah, that's what you would say. You would say something like blogs and you could say this, right? And you say you say or, and then you close it here, right? So let's make this a little more readable. And this would be Everyday Astronaut. I forget the name. Elon Musk. So everyday. Let's grab that. And this, we'll put it right here. Okay. So if we run that, there we go. So notice that we got a couple from Elon and a couple and one from Everyday Astronaut. See that? So yeah. So we can totally do that. We can run and or you can make fairly complex, arbitrarily complex Boolean expressions. Okay. Yeah. So now we're going to join 3 tables, right? We want the users, the blogs, and the posts from a particular user called Everyday Astronaut, right? So let's grab that and let's run that. Let's run that. There we go. So we have Everyday Astronaut has one single blog, and in that blog he has 2 posts. There we go, right? One is praising SpaceX, and the other one is saying that SpaceX stinks. All right, so there we go. So we got the username, which is repeated here, and then the blogs. There we go, right? Just one blog, and all the posts that come from those blogs. Right. So we ask you to join also 3 tables. I joined user, blog, and post. You're going to be joining blog, posts, and replies. Blogs, posts, and replies. Right? Whose blog name is Everyday Astronaut. Okay. So and then retrieve that value, and then just print it out. Okay. All right. Now we're going to aggregate. So aggregation is going to do the following. Is going to let's copy this. So aggregation, like we introduced last week with in relational algebra, right? We talked about that you can grab data that and take a look at a field and see where that field repeats, right? And then those fields you can group on those fields, right? And then create groups in there, right? So for instance, take a look at the rating table. We're gonna group by rating post ID. So let's look at the post ID field in the ratings table, right? So let's go in the ratings. Let's open that up. Let's see what we got there. And so let's look at the post ID because that's what we're looking at. So we have values 1, 2, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2. Let's sort it by post ID. Notice that we just have post ID is just a value either 1 or 2. But we could totally add more posts, obviously, by 3, 4, 5, any one of these, right? Okay, so basically what this group by is going to do is that I'm going to come back with two groups. The group where post ID is 1 and the group where post ID is 2. Okay? And so now that I've created these two groups, what do you want me to do with the rest of the fields? Right? Because if I have a group that with post ID is 1 and I have another group with post ID is 2, what do I do with user ID? What do I do with likes? What do I do with them? Because all these 9 records are going to be collapsed into one row, are going to be squished, where all of them have post ID equals to 1. Well, what are we going to do with all these? Are you going to squish them? You have 1s and 0s. What are you going to do? All these are 3s, 4s, and 5s, right? How are you going to squish them? How are you going to combine them? We need to say we need to determine how do we want to combine the values of these 9 records into a single value. Okay. Well, what we're going to do is that we're going to leave post ID as it is. We're not, it's already squished, right? It's just the value either 1 or 2, and it's going to come back with just 2 rows where post ID is 1 and post ID is 2. But what do we do with the other fields? Well, we're going to aggregate them, right? We're going to take the likes in the ratings. We're going to take the likes, which are right here. Here are the likes. Here are the likes. See that? And what are we going to do? We're going to sum them up. We're going to add them up. So basically, we're going to say, okay, for group 1, we're going to count 1, 2, 3, plus 0, plus null, 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 null. That's it, right? So that gives me a 3, right? So the result is that it's going to come back with post ID 1 and then 3. And it's going to be under a column called likes. See that? What about the other group? Group number 2. Group number 2 is going to count the likes too. So 0 plus 1 plus 1 plus 1 plus 0 plus 0 plus 1 plus null, 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 null. So it comes out to be what? 4. So the second group is going to come back with 2 and then 4 under the likes. Make sense? Well, let's try it out. Let's run it. Oops. Wait a minute. Let's run that. There we go. See that? There's post 1 is up, sums up to 3, and post number 2 sums up to 4. Make sense? Right? All right. So what we're asking you to do, right? It says, once you've done that, practice it. You practice now, right? What we're asking you to do is, same query, almost same query, but instead we want you to average out, right, all the scores under the rating, right? Basically, right, you're going to take the same ratings table and the same 2 groups, right, group 1 and number 2, but we want you to average out the scores, right? So basically the average of all these values, which comes out to be, I don't know, 3 plus 4 plus 5 plus 5 divided by 4, whatever that average comes out to be. And for group number 2 comes out to be 4 plus 4 plus 5 plus 4 plus 3 divided by 5, right? That's the average. And SQL already has a function called average. So basically it's going to be almost the same as this, but it's going to be the average of the scores. Okay? And the column should be called scores. Make sense? All right, so that'll give you a chance to practice grouping. All right? All right, excellent. Let's keep going. So next, we're going to play around with what we call inline views. So inline views, what inline views allows you to do is, something that one of your colleagues suggested, saying, all these results that are coming back, they look awfully much like plain tables, right? I mean, they look just like tables, don't they look like tables, right? So the question, the following question that you should ask is, could we treat it as if they were tables? I mean, look at this. This is a table, has got 2 rows, got 3 columns, right? And this one has this one has, again, 3 rows, 2 columns. Can we treat it as tables? Actually, we can. We can treat these result sets as if they were tables. We call them inline views, right? Maybe, so basically what happens is that a select statement, or the output of a select statement, which is a result grid, right, a result set, can be treated as if it were a table, okay? And here it is. See that in the from clause? The from clause is grabbing data from 2 tables and a third virtual table that looks just like a table, which is an output, the output of the select statement. We can treat it just as if it were a table. We're going to give it a name, right? Whatever that comes back to, we're going to give it a name, right? And then you can treat it as if it were a table, and then do joins and do everything you could do with the tables. You can also do with inline views, right? Inline views. So basically, the select statement is what? This select statement is basically the select statement from above, right? So same select statement from above, but we have embedded it, right, inside an outer select statement, right? An outer select statement, right? And then joined this table with another table. See that we're joining this inline view, which is right here. We're joining it with the post table, and then the post table we're joining with the blog. So basically, we're grabbing the name of the blog, the name of the post, and then we want to know the likes, because this query over here is very cryptic, right? This query is very cryptic. It says that post 1 got 3 likes and post 2 got 4 likes. It would be better if I knew what the post was, right? The actual post, to see, all the likes, all the 3 likes, right? The ID is not very useful. So I would like to go fetch the actual post, to know what is it that they posted that people liked. Okay, so I can join. I can take the results from this query, and I can join it, so I can fetch the actual post. Here are the likes, 3 and 4, but now I can see the actual post, and I know what blog it belonged to. Okay, so we ask you to do the same thing. It says, well, you had created an inline view before that calculated the scores, right, as the average in the ratings table. Well, use that to create your own inline view, right? You create a new inline view that comes back with the aggregated scores, right, the average scores, right, with the post and the blog. Okay? All right. Yeah, so that's the assignment for this week. Again, read through this, grab the database that we provided for you as a starting point. Okay. All right. Any questions? All right. Excellent. Let's move on then. All right, so we've looked at the assignment. Let's take a look at, let's start talking formally. Let's start talking about SQL queries. All right. All right, let's talk about SQL queries. All right, so what is a query? Right, so up to this point, we've been building the structure of the data, right? We've been using the create statement to say, this is a table, and this is the primary key, and these are all the fields in there, and maybe foreign keys that relate to other tables, blah, blah, blah. We've been creating this structure. Now we have to put data in there, which we haven't talked about just yet, right? And once we've put data, inserted data in there, we need to be able to retrieve that data. Now, retrieving data is, some of the more common things that you're going to be doing mostly with the database, right? It is, by far the most important aspect of interacting with the database, right? Your day-to-day, tasks of working with the database is mostly going to be around retrieving data from a database. Okay, so you're going to become intimately familiar with these statements, and these statements have the form select fields, from tables where predicates, okay? And this is the most common syntax, right? Where you say, okay, I want to retrieve these fields, from these tables, right, that meet these criteria, okay? And basically, it's the command. What it does is that it gathers information from multiple tables, right, and from different columns and different records, right, and then collates all that information into one single result set, right? So basically filtering out all the records that meet the particular criteria, right, and then averaging things out and summing up and counting, blah blah blah, coming up with a subset of the data from millions of records into maybe just a couple. Okay, we are going to be using this database all throughout the semester, which is just basically a couple of students, courses, departments, sections, and whatnot. Right, so the same database all throughout. And so here's a couple of really simple queries, right? That that we're going to use to introduce some of these concepts, right? So here's a simple one. From a given table, right? This is the data source, the source of our data. Retrieve certain fields, right, in that table. Okay, so I'm just pointing out here a couple of syntax facts, right? That here are the fields. And notice that I'm using the dot notation saying that these fields presumably belong to a table called student, okay? And there's the table from where we are driving the data. Now, here we're prepending with the dot notation the name of the table from where we're grabbing the field, okay? Now, the prepending or prefixing the field that we're grabbing is optional. Okay, it is not required that you put the table in front of the field. It is only required if this field is ambiguous, right? If you have two tables, right, and they both have the same field name, then yes, you definitely have to prefix it, right? Otherwise, you get an error saying that it's ambiguous. I don't know if you mean S name in table A or S name in table B, right? So only you need to prefix if it's ambiguous. Okay. The other thing is that if you're going to prefix, oftentimes it's useful to create an alias to the actual name of the table. So the name of the table might be student, but you can rename it. So remember that we had the rename operation in relational algebra, right? And so you can rename it locally, right, to a local variable, so that it could be easier, right, to use this alias instead of the actual table name, right? This table name might be very long, or it might have a very cryptic name or whatever, right? You can give it a local variable name so that it'll be easier to use it elsewhere in the query. Yes? This is especially going to be useful later on when we talk about self-joins, right? A table that is referring to itself, right? Now, if there is no ambiguity, right? If you have just one table, then it's not ambiguous. The fields are not ambiguous. Let's see in the chat. When do you recommend using the full name versus the local name? No, I mean, there's no reason why you would use the full name, right? It's oftentimes better to just use an alias, which is much shorter. Otherwise, it would make it really big and hard to read. Anytime that it helps understand the query, I would use either the shorthand notation alias or the name of the table, only for folks when they're reading it for documentation purposes, to make it clear where you're getting the data, right? Like for instance, I wouldn't use a shorthand or an alias that makes it even harder to read, right? That I use a name that actually makes no sense, right? Or I would use, if you use a single letter that make it even worse, harder to read, if you use XYZ that have no no meaning. It doesn't add any meaning to the query, right? So I would use aliases when it's clear that it makes it easier to read the query. Yeah, so if there is no ambiguity, right? If there's no ambiguity, there's no point on adding a prefix to the field, right? So right, these fields can possibly only exist on the single table that you're using. There's no point in adding any prefix. Okay. Also, there's a shorthand where if you want all the fields, well, you don't have to list them all, right? You can just say star, and that brings in all the fields from that table, unless you only want a certain number of fields, right, or specific field, then you can list them here. That's exactly what we introduced in the previous section when we talked about projection, right? Remember in relational algebra, right, you have the operator projection, right, that said, I only want a subset of the columns. I don't want all the columns. So this is exactly how you accomplish it in SQL, in SQL.
Professor?
Yes.
Does the asterisk also act like the
Sorry, you cut off there the last minute. What'd you say?
the wildcard?
Wildcard? No, here it says, no. For the wildcard, we'll see in a minute, you use the percent.
Oh, okay.
Yeah, no, you use the percent.
All right, cool. Thank you.
Yeah. Yeah. So here we have a simple example here where you might be joining two tables, right? We'll see joining, what that means in a minute. But you're grabbing some data from one table, department, and then some data from another table, employee, and where ID here might be the primary key, and here you have a foreign key that is referencing that primary key, right? And so here, right, notice that we're grabbing the department name, presumably from the department table, and employee and the name of the employee from the employee table. And it is clear that name only is in the employee table, and the D name is only in the department name. So there's no need for prefixing the fields. But if these would have been like that, where you had a name field on both tables, then yes, here, right, it would be ambiguous that which name belongs to what table, right? So you would have to prepend it, right, with the table name in front of it to retrieve like that, right? But in this case, right, we don't have that case. We don't have that ambiguity, so there's no need to. Oops, why did it jump down? There's no need to add the prefix, right, because there's no ambiguity. Right, so here's just a couple of other queries, right? We're having from the persons table and the we're just retrieving data from the persons table, and we're retrieving only the last and the first, right? So basically, this is what? This is a projection. Right? This is just a projection. It's taking the persons table and it's doing a projection where I only want these two columns, right? There's no select here in the relational algebra sense, right? It's not select, it's entirely a projection. It's returning the entire table persons, right? But only retrieving two columns, which is last name and first name, right? Just these two. And it's dropping, right? It's not showing me the other three columns. So it's a straight projection, okay? Later on, when we see where clauses, right, in a minute, right, that would be a select, right, with a predicate, okay? All right, so distinct. If you have fields or columns where you have values that are repeating, you can specify that you don't want to repeat the records where values repeat for a specific column, right? So you can optionally put a distinct keyword in front of the column that you want repeating. So for instance, if you have city and you have a lot of folks living in Lowell, right, and you just want the first one, for instance, right, you can say distinct city, right? It'll filter out all the ones that repeat. All right, so let's take a look at some more advanced things here. Let's first let's consider the fact that the I guess it would be great if I have a data types here. Data types. There we go. Yeah, so the database allows you to declare different various data types, right? When we looked at the create statement, remember, right, where certain things would be varchar, integers, floats, small. I mean, there's tons of data types, and each data type has different operations that you can do on them, right? So for instance, the numeric data types, you can apply all sorts of arithmetic operations. The varchar strings, right? You can apply all sorts of string operations. So let's take a look at them real quick. And this is only a very brief overview of all the things that are available. You know, the actual specification is extremely large, and definitely, you know, we'll be introducing them as we go, or definitely you can follow up on the documentation for whatever database you end up using. So yeah, and different vendors will have some proprietary function, some proprietary data types, and definitely, you know, follow up with those specific vendors, whether you go with Oracle or you go with Microsoft SQL Server, or you go with MySQL. So yeah, so here's just a couple of functions. For instance, for the strings, you can convert strings into lowercase, uppercase. You know, you can trim the leading spaces or the trailing spaces. You can, you know, calculate the length of a string. You know, things you would expect from any programming language, right? You can calculate the substring, you know, between a starting point and the length of that string. You can also, you know, as you log in to the database, you can retrieve the currently logged in user, which is great using it for queries, so that you can maybe retrieve information that is specific to a user, right? So if I log in and I use my query, all my queries will be based on that current user, me. Now, if someone else uses the same exact query, they will get data that is relative to them because they're logged in as a separate user. You can concatenate strings with the double vertical bars. You can use like, right, to do some pattern matching, and use wildcard, like someone was suggesting there, right, that you can compare strings using wildcards. Yeah, so let's take a look at some more string operations. And let's take a look at the like, right? So like allows you to do some pattern matching with strings, right, and say, well, does Einstein, you know, match this particular string? And returns true or false. And you have you know, you have dash, you know, underscores can match a single character, and, you know, percentage can match any number of characters. Yeah, so for instance, here's an example of how you would use it in the select statement. You know, in the where clause, although we haven't looked at the where clause just yet. We'll introduce the where clause in a minute, where you can say, well, I'll retrieve certain records that meet the criteria of some column name matching a particular pattern, right? So for instance, you can say, you know, I can take a look, I can take some records from the persons table and compare it against a particular field being equal or pattern matching that starts with LO, so Lowell, for instance, right? And by default, the string manipulation, string comparisons are case insensitive, right? By default. You have all sorts of date operations that allow you to do, you know, date arithmetics, allow you to subtract dates, allows you to add weeks, add days, subtract minutes, right? And all sorts of plethora of date operations, right? By default, the date format is you know, 4 characters for the year, 2 for the month, 2 for the day. Although, you know, different vendors have additional formats, right, that are specific to those vendors. And you know, it has very extensive support for date arithmetics. you can add intervals, you can add a day, you can subtract the month, you can subtract 2 dates to know the time between those 2 dates. Very, very powerful. Allows you to also get access to the current dates, right? So your queries can be based on the current day, right? And so well, like getting a calendar, or based on today's day, what do I have to do today, right? So all those queries that you see that are based on calendars, use the current date. You can also you can extract different portions of a date, right? So you can retrieve the year, the month, the day, right? So you can use it in additional operations, right? You can add intervals, like you can add 7 months to a date, right? And it gives you the resulting date, right? You can subtract dates to give you that there's 5-day intervals or month or years or whatnot, right? So very, very powerful support for dates. Now, different vendors will have slightly different support for dates. So definitely encourage you to take a look at the specific documentation for whatever vendor you end up using, right? MySQL has these formats supported. SQL Server has a very extensive support of different formats, on being able to format it in many different countries and formats depending on your region. Also, each vendor has extensive support of different functions that allow you to manipulate dates, right? SQL Server has slightly different set of functions that, but a lot of them are very similar to each other. And again, I encourage you to be familiar with whatever vendor you end up using at work. Okay, so here's just a couple more examples on using specifically SQL Server formatting that allows you to format dates in all sorts of ways, using a shorthand, a little more extended format, or using formatting like in European style using periods, or extended format in European format, which is year, month, and day, using periods. So it's got a plethora of formats that you can use with these codes that are specific to the vendor. Okay, you're not required to memorize any of this. You won't be asked about it, but certainly you should become familiar if you end up using any of these commands for those particular vendors. All right, so let's focus again on the select statement, and let's play around with some of the commands that we just looked at. Okay, it would be nice if there'd be dates here. Yeah, that would be nice. There we go. Okay. All right, and this is SQL queries, or the select clause. The select clause. There we go. Okay, so let's take a look at the select clause, right? So the select, right, is as we saw earlier, right? That's 28. We saw earlier, right? We saw that all queries have these 3 parts, right? These 3 main parts. They have more parts, but these 3 parts, each one of them is referred to as a clause, right? This is the select clause, the from clause, and the where clause, right? And so let's take a look at the select clause first, right? So in the select clause, right, what you do in the select clause is very much what you would do in the projection, right? In the relational algebra, right? You basically, you're going to say, what fields do I want? And in there, not only you can list the fields that you want, you can also create new fields, right? And if you remember in relational algebra, we call that extends, right? Extends in relational algebra is that you can add fields that are calculated fields. Yes. For instance, the example that we gave you was, for instance, coming up with a full name, right? And a full name could be the concatenation of a first name and last name. Now, which first name and last name are very common fields that you might want to store in a table. But the full name would not be an appropriate field to store in a database permanently, right? That would break third normal form, because full name would be a field that depends on two other fields, yes? And we don't want any dependencies between the fields. So we would not have full name as a field in a database, in a table. Okay, instead, it would be an extended field, right? It would be a field that we can calculate on the fly whenever we retrieve data from the database, right? We can grab the first name, the last name, concatenate that, and then we would get the full name, yes? Well, you would do that all in the select statement. So the select statement allows you to retrieve actual fields stored in the database, plus it allows you to calculate and add or extend, right, new fields that you can generate on the fly as you receive data from the database, right? So here are examples of, grabbing fields from the actual table. Plus, we're going to add and extend two new fields, right? One called the graduation class, and the other one is the college field, right? And they are going to be calculated as follows. One of them is going to have always the same value, right? It's just going to be BC, right? So we're going to have a column that just say BC all the way down, okay? The other column, the other extended column here, called graduation class, and the way we name it is using the keyword as, right? And that's how we name the field. And on the left-hand side is the actual value that we're going to put in there, right? Usually values are just the values of the fields that are in the database. But these are fields that don't exist, right? We are just inventing them, right? We're creating them out of thin air. Is a dash a keyword too? Oh, you mean this over here? Yeah, no, this is an arithmetic operation, right? So here, we're calculating the value of this new column on the fly by subtracting, right, this actual field that is stored in the database, and we're subtracting 1863, right, from all the graduation year of all the students. Yes, okay, I see that, thank you. Yeah, so the new values for this brand new field is going to be the subtraction between the graduation year of that particular student minus 1863, right? Basically, presumably, this is a college that was founded in 1863, and we would like to know this particular student, what graduation year or what graduation class are they, right? So if they graduated in 1867, then they are the 7th graduation class, right? 1867 minus 1863, that's 4, sorry. The 4th graduation class, graduating class, right? From Boston College, okay? So yeah, so here's an example, right? So, this is, they are the 100, all these folks, Joe, Alice, blah, 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 blah. Well, let's change a little bit, maybe 5 and 5 and 6. All right, so all these folks graduated, very recently, and so they are, they graduated 153 years after the founding of the college. Okay, so these 3 fields on the left, these are taken from actual records and columns that are stored permanently in the database, whereas these 2 were computed fields, right? That were computed on the fly as we retrieve data from the database, right? We calculate these 2 columns, yeah, for display purposes only. This data does not exist in the underlying database, right? We're just extracting and calculating them on the fly, right? All right, so a couple more examples, right? So here is a select, right? In the clause, we are retrieving these 3 fields that are actually stored in the database, right? In the student table, okay? And now we're going to calculate a couple more things, right? And we're going to start adding a couple things here and using the as keyword, right, to rename our columns, right? So let's see, let's add a couple things, right? So here it is. So right, if we would retrieve this regularly, the column that would come up in the select statement would be also called SID, right? The column is just basically the name of the column that we got from the original table. But we can rename that. We can rename that and says that in the result set, right, I don't want to use the original column name. I want to use a new column name, new SID, right? Let's see in the chat. Would it be better to select things using condition selectors or use where with predicates? Yeah, no, we're going to see where in a minute, a little later. So first we're going to spend some time with the select, then we're going to spend some time in the from clause, and then we're going to spend some time in the where clause. So we're spending some time in each one of the clauses. Yeah, we'll get to the where in a minute. So yeah, so we are renaming the column in the SID. We're renaming it to new SID. We're leaving the S name the same. So we want the student name all by itself, and then the column, we're going to leave it S name. And the graduation year, we're going to rename it to graduation decade, right? Because we're going to do a couple of arithmetic here. We're going to use this graduation year to calculate in which decade did you graduate, right? Did you graduate in the 2000s, 2010, 2020s, 2030s? When did you graduate, right? And we're going to compute it based on the year that you graduated. Okay, so let's keep going. Okay, so we are going to calculate a new student ID based on the original student ID by concatenating a constant string. We're going to concatenate the original student ID, right? So the new value for the new SID will be the original SID of the student plus the student number, right? The student number. So concatenating a string in front of it, right? And that's what it's going to be the result in this new column. Let's keep going. Let's now in the graduation decade. How do we calculate? How do we calculate the graduation decade? Well, what we're going to do is that we're going to grab the graduation year, and we're going to compute. So if you're in 2012, we want it to be that you are in the decade of 2010, right? If you're 2017, then you're in the decade of the 2010s. You know, so if you graduate in 2003, then you are in the decade of the 2000s. Yes. So basically, we're going to calculate whether you're between 2000, 2010, 2010, 2020, and so on and so forth. So how do we do that? Well, we can do that as follows. We're going to grab the graduation year. We're going to divide it by 10. We're going to cast it into an integer. So basically, if you're 2003, you're going to become 200.3. And when you cast it, it's going to just drop the 0.3, the decimal. You're going to end up with just 200. Then that we're going to multiply times 10, and that's going to bring it back to 2000. So 2003 becomes 2000. 2017 becomes 2010, right? 2023 becomes 2020. So that gives you the decade that you graduate. So this is just giving you examples on what you can do in the select statement, right? In the select clause to bring in some values from the underlying table, leave them some alone, and then maybe generate new data, right? For display purposes. Okay. Does SQL not do integer division automatically? Yeah, you would have to force it by adding like a point something here. Then it would be floating point division. Or actually, no, if you don't cast it, right, it will do floating point division regularly. So because we're casting it, right, it's dropping the last digit. So here's an example, right, of having some folks graduating. Let's make it a little more interesting. This is 2010, 10, and then 20. Okay, there we go. All right, so let's look at something a little more complex, right? And this is case. Let's do something a little more sophisticated and advanced, right? So in this select statement, these values, you can have something that is even more powerful, right? To calculate these values on the fly, right? Let's take a look at it. We're going to use a case. So case is very much like an if else, nested if else, right? Or something like a switch statement, right? In other languages, right? Where you can have a switch on a variable, and then depending on the value of that switch, you can you can come back with different results depending on the value compared against a constant. Or you can have nested if else, right? And then you can compare, you can run an expression, and if it's true, that's what you evaluate to, right? And so these values here, the values that are calculated, these values right here, these values here can be calculated not only using this string concatenation, not only can you do just simple arithmetic, but you can do some logic, where you can do branching and iterations, right? So you can do very sophisticated calculations on what you're going to put in there. So let's take a look at one of the more advanced examples where we're going to use case. So case, the default has two syntax. It has two syntaxes. The one of them is as follows, where you can say, case when condition then, right? Where you compare a condition against a value, and then you can return from multiple whens, or each when can have its own else, and give an if statement its own, right? So let's take a look at an example. So here it is. So imagine you had a really simple table, very, very simple table. Table A has values 1, 2, 3. That's it. Something really, really simple. So you could just say, select A from test. That's it. That gives you what? It gives you this first column, right? Well, we're going to add a second column. So notice that it says A, comma. So this is going to be generate a new column. It's going to generate a new column whose value is going to be whatever the then comes out to be, or the else. See that? So the value of this new column is going to be, if A is 1, then the value of the second column will be the character string 1. Okay? If the value of A is 2, then the character string is going to be 2. Or else, if it's not 1 or 2, then the result is going to be other. See that? So you can very, very sophisticated, calculate these values on the fly, using, string concatenation, simple arithmetic, or even, if else, nested if else statements. Okay. Now notice this is much more powerful than a switch statement, because a switch statement just compares a single value against a constants, right? Here, each when clause has its own predicate, right? So it's much powerful than just a plain old switch statement. Is there an equivalent else if? Yeah, this is an else if, right? It checks to say this. If this is false, it goes on to the next one. If this is false, it goes on to the next one. So these are all else ifs. Else if, else if, else if, yes, right? Or you can use the regular switch statement where you only have a single expression, right? This is just like this, the normal switch statement, which compares a single expression against several constant values, right? Comparing it against those and then retrieving. So you can implement the previous example, using something simpler. You can say select A, and then he's going to compare the value of A against several values of 1, 2 constants, right? And then return the values 1, 2, or other. Very, very powerful, very, really cool. Okay. Now let's use this, right? Let's use this example to calculate whether you are an alumni, right? Whether the student is an alumni, meaning somebody who has already graduated, or if someone is still yet to graduate, right? So for instance, we could do a select statement, which we return all the fields for the student. Here's a student, all the fields for the student, plus an added field here, which we're going to call alum years, meaning how many years have you been an alumni, right? And what we're going to do is that we're going to look at the current year, right? The current year. We're going to extract the year field from the current year, and we're going to subtract the student's graduation year, right? So we're going to have a difference between where we are now and when did you graduate. Okay, so if that value is positive, right, that means that you graduated in the past, meaning you're an alumni. If the value is negative, that means that you haven't graduated yet, right? So you're still a student. Okay, so depending on whether this is positive or negative, well, we can determine, right, how many years have you been an alumni, or if you're not an alumni at all, that you're still in school. Okay, so using this strategy, this same strategy, we can take the original value, we can take this query. This could be an inline view. This could be an inline view, and use it here, as a parentheses, right? Just take this. Imagine you grab this whole thing, right, and you can put it in a parentheses right here, right? Embed it, okay, and then naming it as Q, okay. So we can take the alum years, which is going to be either positive, negative, 0, right? And so we can take that and check to see if it's greater than 0, then we know that you're an alumni, right? Otherwise, right, if it's 0 or negative, it means that you're still in school, right? So we can generate a graduating status saying whether you're a student, or you're still a student in school, or you have graduated and you're an alumni. Okay. Yeah. So very, very powerful, right? Now, there's an alternate syntax in the switch case, which is much more terse, much more compact, right? Which is basically an if, right? So if, this is very similar to the if statement that you would find in, for instance, in Google Sheets or in Excel spreadsheets, right? Where you can, the first one, you have a predicate, whether it's true or false. And if it's true, it returns the second argument. If the first argument is false, it returns the third argument, right? Very much like it's Excel, right? And that value, you can then give it a name in the column, okay? All right, now, okay, so that's all the select clause, right? The select clause, and there's plenty more we can say. We'll come back to it, as we go further. Let's now step back and let's take a look at the from clause. Remember, there's 3 main clauses, right? There's the select clause, the from clause, and then there's the where clause, right? We took a look at some on the select clause. Let's spend some time on the from clause, okay? So yeah, so we spent some time in the select. Let's take a look at the from clause, okay? So in the from clause is where we list all the tables that we are extracting data from, right? From, and then the tables that the data is coming from, right? Now, just like this, right? Here, basically is saying that we're going to consider all the possible combinations of these 2 tables, right? If it's just a single table, then obviously, we know what that means, right? It's just, we're considering all the records in that table. But if you have 2 tables, then what values, which records are you considering? Well, this means that we're going to consider all the possible combinations of one table or in both tables, right? So if you have, for instance, if you have 9 students and 3 departments, you're going to end up with 29 different combinations, right, of all the students combined with all the departments. Even if some of those students are not related to any of those departments. Regardless, right, this means that the way it's implemented down below, it's going to iterate, right? It's going to iterate over the students table in an outer loop, and then the department is going to iterate in an inner loop all the departments, right? So for each student, it's going to start the first student, and it's going to start the first department, and for that student, it's going to compare against all the departments. And when it's done, it's going to start all over. It's going to go into the next student, and it's going to compare it against all the departments. And then we'll start all over. We go into the next student, and then continue going all the departments. So basically, it's walking and considering all possible combinations of students with departments. Yes, right? And so, but obviously, we're not going to want all the possibilities, right? And that's where we're going to introduce joins in a minute, right? We're going to introduce joins, and joins is going to allow us to filter out, right, that we don't really want all 27 or 81 pairs of students, right? We only want a few of them. So here's a when you have tables, right? When you have tables, multiple tables, you have to be careful because across multiple tables, you might have fields that might have the same name, the same columns named the same way across multiple tables, right? If that's true, then you have to make sure that you disambiguate, right? You append or you prefix in front of the field, right, the name of the table so that it's not ambiguous. Which one do you mean? So here's an example that I mentioned earlier, right? That's very useful. If you have, two tables, even the same table that you're considering all the students mixed in with all the other students, right? And then because you have student name in both the same table, then it would be ambiguous to use S name twice, right? So that's why we prefix it, right? And we give an alias, right, to the same table so that we can reuse here in the query. And you might say, well, why would we want to possibly do that? Why would you have students related to students? Well, maybe students to students might not be very intuitive, but imagine this would be instead employee, right? And this is also employee, right? And so now it's not that crazy, right? Because you might want to consider relationships between an employee and another employee. It might be that some employees are, just individual contributors, but some other employees might be the managers of those individual contributors, right? And there might be managers of managers, right? And you might have directors, and you might have, project managers, and then you would have, vice president and whatever, right? So you create these relationships, this hierarchy of employees managing other employees, going all the way up the chain, to the CEO and then the board, board of directors or whatever, right? So you have all these employees pointing to each other, right? So this would be totally fine, right? Would make total sense. Where you might do a join of employees with other employees, right? And so you need to name the employee table twice, right? And you need to use aliases to be able to distinguish which one do you mean, right? So all right, so let's now take a look at the case where even though you can combine and make all the combinations, probably you only want a subset of all those possible combinations, right? Let's see, there's a question in the chat. Is there? Yes. Yeah. So there might be a so for instance here, students and departments, right? As I mentioned earlier, right? This creates all the possible combinations of students and departments, right? But we might not want all the combinations. We might want only a subset, right? We might want only say, well, I only want those students that are in a particular department. I don't want Joe that is in chemistry mixed in with Joe with math. He's not in math, he's in chemistry. Why are we considering all the possibilities? So we can filter that. We can filter it by using the join keyword, right? So the join keyword says, hey, I'm gonna combine all the possibilities or all the combinations of student and department, but, right, I want to filter. I only want to keep the ones where one of the records is referencing the other record, that there's a real relationship between those records, right? Filter out the ones that are not related, throw all of those away, only keep the ones where are related, right? So join basically takes the cross product, right, of all the possibilities, and then allows you to filter on the ones that actually are related to one another, right? So join allows you to do that. And if you remember in relational algebra, that's exactly what we did, right? We had the cross product, then it was fed into a select with a predicate, right? And this is exactly how you do it. This is how you implement it using SQL, right? This is what? This is a join, and this is a projection. Right? You're projecting those values. Yep. Now, yeah, so the syntax of joins is a very, very powerful and useful operation, and we're going to be using it quite often here in class, right? And basically the syntax is that you do the projection, selecting the columns you want, and then you join the tables, the two tables that you want to join, right? Table 1 and Table 2. Table 1 oftentimes is sometimes referred to as the left table because it's to the left of the join, and the table here sometimes is referred to as the table on the right table. Okay, so the left table and the right table, and then on usually on two columns on both tables that are somehow related to one another. Typically, these would be foreign key, primary key, right? Foreign key, primary key, right? Now, this syntax that we have here, right? The most common type of join is what we just call maybe just plain old join, right? And sometimes it's also referred to as the inner join, or sometimes also referred to as the natural join. Okay, natural join, right, is the most common and the one that makes most sense, right? If we have students enrolled in the department, then we want those, right? The ones that are related to each other, right? But there's more, right? Not only do we have the natural joins, but we have also what are called the left join and the right join, right? And what we mean by those is that sometimes not only do we want the ones that are related to one another, but sometimes I also want the ones that are not related to one another as well. Okay, and here I have a choice. If I find the ones that are related, okay, which is the natural join, I might want also the ones from the left table that are not related. Right? So bring over, not only the ones that are related, but also bring some of the records, right, from the left table, which are not related to each other, right? Or the ones from the right, the table on the right. Or I might say, just bring me everything, right? Bring me the ones that are related, then bring me the ones on the left, and then bring me the ones on the right. Okay, I might need the whole thing, and that's called a full outer join, right? Very, very expensive. Okay, so here's an example of just a plain old just inner join, right? Of just joining this persons table with this orders table, which notice we have this person IDs 3311 referring to these three here, 1 and 3. Okay, and somehow this one is not related to anything. Let's see on the chat. It says, how do you determine which table is on the left? It's your choice, right? You decide what table is on the left. So table 1 here happens to be on the table on the left-hand side, and you can flip them around any which way you want. Okay, you can put them anywhere you want on the left or the right. Okay, no, I mean internally. Not sure what you mean internally. What do you mean by internally?
Sorry, I think I got it now. Yeah, okay. I think I got it. Thank you.
Sure. Yeah, so this one is just a regular join, right? We're going to join these two records, right, with these orders over here, and notice that there's here an order that is not referencing any person. So a regular plain old natural join or inner join is just you just use the keyword join, right, on the fields that you relate primary key and foreign key. And indeed, we have Boone and Garcia, right, that are related, right? So here's Boone and here's Garcia that have records. They have these two and these two, okay? Right, and that's what you get. And that's the most common use of a join. But you might also want data from the left-hand side or from the right-hand side, depending on what's convenient to you, grabbing data from the table on your left or your table on your right, okay? Which, for instance, if you do a left join on the same data that we had earlier, right, we want to see which ones don't match. For instance, this one has no match with any of the persons here, and we have Dole has no match on the order table, right? So again, depending on which one is on the left, we might retrieve this missing record over here, not matching record, or this one over here, not matching record, right? So for instance, if we have persons on the left and orders on the right, the left join would retrieve the records on the persons on the left that have no match on the right-hand side, right? So there we go. Notice that over here, we have no data. Or vice versa, right? We can, oh, before we get there, let's look at an example. One might say, well, why would we want to do that, right? I know I ran out of time. If you feel that you need to go, please, feel free to drop the meeting. I'm just gonna go on for another couple more minutes, and you can certainly take a look at this later on in the recorded version. So yeah, so if you want to stick around, just 5 more minutes. Yeah, so the one might ask, well, why would we want to do that? Why bother bringing Dole here if he has no equivalent? He has no match. What's the point, right? Well, here's an example when you might want to do that. So just imagine that you have these 2 tables, right? And you have a staff at the university that has social security number and first name and last name, and there's another table called spouse that records information about your wife or husband that has its own primary key, but then it has a foreign key that refers to the staff that they are married to. Okay, now imagine we want to send invites for Christmas party at the end of the year, and we want to invite all the staff, right? And we want to invite their spouses. Yes. Well, we write a query and says, okay, we do a simple join. Now, if we do a simple join, we're going to only get those staff members that actually have spouses, right? Right? What about all the staff members that don't have spouses? Are you not going to invite them just because they're not married, right? Instead, you would want to say, okay, well, what you mean is that, find the names of each staff member and his/her spouse, if any, right? So, bring in the spouse if they have a spouse. If they don't have a spouse, fine, don't bring in the spouse, but I still want the staff, right? So to do that, you would do that, if you're doing an inner join, right? Inner join is the same thing as a join, right? You would only retrieve the spouses, the staff, you would only retrieve the staff that have spouses, right? But that would be a problem because you would not be inviting folks that are not married. Instead, you would use the left join, which retrieve the staff, right, and their spouses. But if the staff have no spouses, it would still bring in all the staff nevertheless, right? It would bring in all the staff, even if they're not married. Make sense? Yeah, so it's very useful. Right join is just basically, saying that instead of the records on the left that don't match, I want to bring the records on the right that don't match, right? And so here, going back to our first example of having persons and orders, right? The ones that don't match here are maybe these orders here that have no match on the users or the persons above. So if you do the right join, right, it's bringing in the orders, right, that have no match on the persons table. Okay. All right. Let's see.
Oh, wow.
I'm sorry. Yeah. And finally, a full join is basically I want to retrieve data from both places, from the left and the right, the ones that match, there they are, plus the left join, right? The records on the left that don't match, plus the records on the right that don't match. Okay, using the full join. All right, we'll leave where for next time when we meet on Friday. All right. Okay, folks, thank you so much.
Thank you. Have a nice night.
All right, you too. Take care.
Thank you.
Thank you, Professor.
Good night. Bye-bye. Oh my goodness, so dark. I think I need a light here.